I thought we'd say a few words around disaggregating data center, a bit about what disaggregation is. I think hopefully everyone knows what a data center is. If not, we'll have a very long night. But fundamentally, I think a lot of us are here to learn, or at least my understanding is the audience is here to learn about, if you're thinking about something entrepreneurial, if you're thinking about doing investing, is the data center a good place to invest in or invest your time or money in the near future, given what we're seeing trend-wise? And so we'll talk a bit about that. But to get us started, let me explain where the data comes from. It comes from a good place. It's not like, but one of the unique vantage points that we have, my partner Matt, who's somewhere in the audience, and I have, in terms of running SDxCentral, is we get a lot of feedback, a lot of indications of what the trends are around data center technologies, around software-defined infrastructure technologies. And where we get these from, we have 170,000 unique visitors a month to the website. And the way they tell us what they're interested in is very simple. They click a mouse, right? So depending on the stories they read, depending on how much time they spend on the stories, where the areas of interest lie, that gives us information around what's going on out there. And because we are a relatively young site, the only reason why people are there is to learn about new technologies, about software-defined technology, so to speak. And we cover all things sort of software-defined from an infrastructure standpoint. And so we tend to get very cutting edge. We tend to get people who are looking at the new trends, who are interested in new trends, who are not afraid of new trends, telling us what the level of interest is in various topics, and that's how we get the data. And so what you see very shortly comes from that. The audience, as you can see, is quite well spread worldwide, so don't be afraid. I mean, the data is quite accurate with regard to sort of international, reflecting the international presence of sort of technology-wise. About half of it is US, that's I guess just the way it is, and then the half is the rest of the world, with about 24% EMEA, Europe, Middle East, and Africa, and 20% APAC. And we have a good mix. One of the strange things we've noticed is, historically, if you talk to technology people, infrastructure technology people, they'll say, are you an enterprise company, or are you a service provider company, or a telco company, right? That's the way people talk. And we were asked a question too, and we said, we're neither, because the reality is that a third of the audience are enterprises, a third of the audience are service providers, and then the rest are industry vendors, analysts, and investors. And what they say to us is that there is some level of horizontalization, if that's a word, going on that makes software-defined infrastructure technologies applicable regardless of whether you're talking about service provider technology, service provider market, or the enterprise market. And I'm sure that the panelists, in terms of their engagements with their own customers, would agree that they see the same trend. So that's one of the things that's happening. Now, beyond that, this is a highly scientific graph of interest level in keywords on the site. So fundamentally, what I did was I looked at the last 6 months, and I said, okay, what are the hot areas, hot articles written by the editors and journalists that we have, and based on those articles and the top articles, right? What are the top keywords that are reflected in those articles? And that's what came up. I'm not going to try to define everything in here, and this is the nature of tonight is not to define and make you SDN or software-defined networking experts or NFV, network functions virtualization experts. The goal tonight is to understand what this aggregation is bringing to the data center and what opportunities that brings along with it. But I think that's an interesting thing. And just look at some of those words, and even to play buzzword bingo. So when Mansour speaks, when JR speaks, when Amit speaks, or when Sudip speaks, you can cross some of those words. In fact, I can go to cross off that intent-based networking one very quickly when Mansour steps up here, right? So we'll see. So as you can see, this is reflective of the industry and the audience. That says that it is accurate. So thank God it is accurate. I've been validated by some of the best funded startups in networking. Right, that's good. All right. If we look at the data center, right, and we talk to enterprises or talk to service providers, right, and we say, what do you guys really care about? And it's not 10 gig going to 100 gig going to 400 gig. It's not about that. It's about elements that are driving the business, right? So these are all business drivers in essence. And what do they talk about? They talk about we want better scale, right? We want better efficiency, we want more agility, and we want more control. And what does that mean? Well, so on scale, what kind of scale are you looking for? Well, some companies out there in networking are looking for cloud scale, right? The really big guys, the Amazon Web Services, the Google Compute platforms, and Microsoft Azures of the world, right? But not necessarily everyone, right? Some want container scale, right? You've heard about container. Anyway, quick show of hands, who's heard about container technology? And we're not talking about the big shipping docks, all those. That's good. So when you talk about container scale, one thing that's happening, and I'm sure we'll hear it again too, is when we went with VMs, and VMware has made a lot of money from VMs. We had tens, maybe hundreds of machines running on a single piece of hardware. With containers, we're talking about thousands, if not more. And so, how do you scale to that, and how do you deal with that? And likewise, in the data center, there's a lot of increased media consumption, right? All those cat videos end up somewhere, right? They have to come from somewhere. And so how do you manage the number of cat videos on the internet across the data centers? I bet one of these days, you'll see a Cumulus data sheet that says, can handle 1,050,000 cat videos simultaneously per second, right? That's when we know that cat videos have dominated the world, right? But it drives a lot of media, it drives a lot of consumption for sure. And so moving on to some of the other business drivers that we'll talk about tonight, that I'm sure underlying a lot of the business plans in a lot of startups, not just the ones up here, but is efficiency. OpEx costs do dominate, right? Very, very often we focus on hardware. We say, oh look, disaggregation or these commodity boxes can save a lot of money. But the reality is that OpEx costs dominate, right? It doesn't matter whose stats you use, but 3 to 5x of CapEx. And so if that's the case, then what do you do? Well, they have the answer. I'm not going to go there right now, but they have the answer to that. Likewise, along efficiency, we're seeing consolidation and orchestration. We're seeing automation. We're seeing a drive towards that. So a lot of very big changes across the data center. Gone are the days of a Cisco CCIE, a certified Internet network engineer, sitting there typing into a CLI, right? I mean, they still exist. It still happens. But that is not the way for the future. And that's not what's happening in the data center today, at any real data center anyway, right? And so let's move on to agility and control. So very often, look at enterprises, service providers, they say, we want agility. What does agility mean? It means I can roll out services very quickly. It also means that you can fail fast. And so if the service doesn't work, you try it again. And that's what you're looking for. It's not that I want 10 gig, 100 gig, terabit connections. It's that I want a data center that can meet my business needs with regard to all these things. And I'm not going to go into control in a lot of detail, but fundamentally, a lot of them are looking for programmability, flexibility. A lot of businesses are talking about the network, the data center technology infrastructure, potentially as a differentiator, as a business differentiator. And to the extent that they can put special sauce or special elements into the infrastructure to meet their business needs, right, they are willing to invest in it. And so how large is this market, right? So that's cool, but if it's $1 million, we wouldn't be sitting up here, right? I mean, JR wouldn't be smiling, right? So data center technology is a big business, right? We're talking about 20, 30 billion, and there are different estimates out there. But fundamentally, if you look at layer 2, 3, it's about 10, 13 billion, and remaining is about layer 4 to 7. I'm not going to explain what layer 4 to 7 is, 2, 3 is, but think of this as switching and routing, and think of that as more intelligent devices that handle traffic that are more application aware. Okay? So we're talking big business here. Moving right along. So disaggregation, the topic of tonight, right? Inevitable? Maybe. Some people would agree, some people would disagree. But disaggregation is taking essentially a monolithic networking device like this, a switch, a router, layer 4 to 7 device, and then breaking it up into different pieces, right? Making those pieces horizontal, in some cases commodity, and making them available from multiple players. And coming up with a set of standards and APIs such that you can actually put them back together again. If you disaggregate, it doesn't help if you can't get a hardware that talks to software that talks to automation. That's useless. You just broke it apart and you're like, okay, well, this is great, right? Doesn't work, right? I've disaggregated. Great, I created value. No, you haven't. You've destroyed value, right? And so fundamentally, with disaggregation, it's great, but what is needed is a way to tie them together. It's a way to provide benefits and innovation at each layer of that is a disaggregated layer, right? Innovation, velocity, high velocity at each layer, and a way to tie them together to get you back value somehow. Right? And so, is disaggregation the only way? Not necessarily, right? If you look at what happened with the PC, I'll give a bad example, but Wintel, everyone knows Wintel, right? So IBM PC, mini computers became PCs, disaggregated. You have software, created Windows, created Microsoft, Intel, and so on and so forth. Doesn't mean it's the only way. That's clear disaggregation right there, right? Because you have Apple. What did Apple do? Pull it all back together, right? In one low package, right? Put a silver coating on it and then charge you 3 times the price, right? That you would pay for a Wintel box. And we paid. I mean, I'm using a Mac. I mean, look, iPhone, right? I mean, look, right? We willingly pay. Why? Is it because we're gullible? Well, no, because it fulfills some need. Integration has benefits as well, right? So now, the size of the ecosystem, the size of the market is different, so I'll grant you that. So, but it's not the only way to make money. So, when you walk away tonight and you say, disaggregation, that's all great. Remember, there's always another way to make money. Doesn't mean that disaggregation is the only way. Okay? And if you're a system integrator or interested in system integration, which I know is not cool, right? And a lot of people, system integration, not cool, right? You can make a lot of money with system integration with disaggregation. Because someone's willing to pay money for all that to come together and work, and for you to guarantee that it works, so that when something goes wrong and your boss calls you and says, you know what, I paid, I don't know, no one from TCS or Wipro or anyone here, right? But, IBM or Ericsson Services, right? But I paid that guy that money, and I'm going to go to him, and he'll solve your problem because the SIs have value, right? Okay. So, anyhow, but a lot of innovation across the board. And so, beyond that, not going to go into great detail here across the board, but the little switch that you see is not the only place you can get innovation in the data center. Across the board, from the virtual switches and the servers all the way to data center interconnects, many places to make money. And I'm happy to send you a copy of my slides. Just drop me an email. That you don't have to take photos or take notes, extensive notes. All right. So we spoke about disruptions, right? Open networking software, open networking, disaggregation, merchant silicon, which we'll explain maybe a little bit more when we get into it. There's someone here who can explain it very, very well, Amit. And then, but there are other ways to make money in the data center, a lot more areas to innovate. Something as simple as topology simplification, right? In the old days, you had all these complicated networks, and now what we're seeing is a simplification of topology around, I'm just going to use a word here, you don't have to understand what it is, like, a 2-tier cloth network, right? It's all everywhere. So topology simplification can bring value because what does that mean? It means that a lot of the things that were invested in the old days go away, and things can be simplified. Now, the question is, in simplification, can you make money? Right? By throwing away the old stuff, can you simplify, reduce, and make more efficient? So it doesn't have to be software, it doesn't have to be code. It can be as simple as infrastructure or topology. And then beyond that, there's a lot more other areas: orchestration, integration, automation, DevOps, and 10, which we'll talk about very, very, very shortly, and more. And so, don't walk away just thinking disaggregation is the only game in town, because there's a lot more innovation in the data center than that. And so with that, I will actually turn you over to Mansour. If that was of interest to you and you want to learn more, there's actually a report at SDxCentral.com on next generation data center networking. You're welcome to read, and it covers a lot of these, actually, the companies here as well. So, all right, Mansour.
Well, thank you, Roy, and thank you very much for the opportunity to tell you about Apstra and to tell you about our journey. So let me start first by telling you a bit about our vision as in Apstra. And Roy described the trends very well, and I'll start by considering all the major trends in the industry: IoT, self-driving cars, Amazon's delivery drones, Facebook's push for virtual reality to the masses, and just consider how much bandwidth you need for all of this, right? I saw a number out there that by 2020 we're going to have 50 billion devices interconnected. So just think in terms of how much networking do you need to support all of this? Every organization that wants to participate in these trends need to beef up their networking. And so one aspect that Roy mentioned is really the operational aspect, right? That aspect yet is unsolved. We have some attempts, but what we need is a major upgrade there, a major shift where really these networks need to operate at large scale in almost in autonomous fashion. And so that is essentially what Apstra is focusing on. I wrote a blog in November, and we defined our concept of a self-operating network, drawing from the self-driving car analogy. And the idea is that we see a future where networks need to just self-operate. And I defined it as it's a network that self-configures, fixes itself, defends itself. And so that is the vision that we're going for with Apstra. And if I continue a bit with the self-driving car analogy, if you look at the self-driving car versus a normal car, it's not about really changing the components themselves, right? Ultimately, a self-driving car looks very much like a normal car. It has an engine and a transmission and a suspension and wheels. What the big difference is that you have this layer of software, right? It's a layer of very intelligent software that sits on top, the self-driving software, that essentially takes for input the intent of the driver, right? And in that context, the intent of, I'm not going to call him a driver, in this case it's just a user of the car, but then he'll punch in his destination, that's his intent. Essentially he wants to get somewhere. And that software essentially takes care of delivering on that. And it delivers on that by essentially configuring all these components, operating all these components, making them work harmoniously together to essentially deliver on this intent. And so that's essentially this concept of, Roy mentioned it, intent-based. It's the idea, it's the notion that the way you interface with your infrastructure and with your network is by describing your desired outcome. And so in order to deliver on this intent, and I'm going to go back to the car analogy, you can't conceive the car delivering on your intent or the software delivering on your intent without measuring telemetry. In fact, a car measures thousands of parameters and is doing a real-time analysis of these parameters continuously, comparing actual state with desired state, and then making the right modifications so that ultimately the car delivers on the intent and gets you to your destination safely. And if I look at other automation systems out there, like even a climate control system, like a Nest thermostat, you specify your temperature, and then you can't conceive the thermostat getting you the temperature without actually measuring the temperature in the room and making the comparison. And in fact, some of these thermostats, they measure many more parameters to get the job done more effectively. And so this concept of intent-based and closed loop are concepts that we have embraced. And the same way in a car you have a self-driving software, that is the component that we are building and we are focusing on as in Apstra. And our product, which is called AOS, the Apstra operating system, is the equivalent of the self-driving software, but for your network. And so it's intent-driven closed loop. And then the third attribute that is important, which is enabled by disaggregation, is that it is also vendor agnostic. And again, this notion of disaggregation sounds so new in networking, but again, when I installed my Nest thermostat in my home, it didn't ask me what type of AC I had in the back end or what vendor my heater was, right? Essentially, it just worked, and that's because you had the right APIs, you had the right abstractions. In fact, the Nest thermostat was effectively disaggregated from your heater system or your AC system in the background. And so building in the right abstractions through disaggregation is critical to delivering on the vision. So I know we have an audience of entrepreneurs here and inspiring entrepreneurs. So maybe I'll take the opportunity of looking at describing why it is that we started a company, right, to deliver on this. And to me, I think this is a checklist of factors that you may want to consider. Certainly in the infrastructure space, you want to go after a really big problem. You want to make sure the timing is right. And then you want to convince yourself that as a team, you're uniquely equipped to deliver. And so let's get into some of these. In terms of the problem, again, Roy touched upon this. Organizations spend $13 billion in switching equipment alone, right, worldwide on a yearly basis. But consider that for every one of these dollars spent on CapEx, organizations are spending $3 on operational expense on average Roy said $5, $3 to $5, same ballpark. But this is an average number. When we go to large enterprises, we see that the numbers are even much higher. Some enterprises spend an order of magnitude more on operating their equipment than buying them. And this doesn't even take into account opportunity cost. What does an outage cost you? What does it cost you in terms of lost revenue because it took you 4 months to actually provision a network to deliver on a business service? If you take these into account, the number is even higher. Now consider this. 80% of those resources are spent on manual operations. And I'm going to actually use the word wasted, because if there is something that is done manually that you can actually automate, you're effectively wasting that resource. And so the industry looked at technologies like ours, and IBNS here it stands for Intent-Based Networking Systems, as Gartner defined it. And we have the same experience with our customers. The improvement is somewhere between 50 and 90%. So if you just do the math, you can see that if you actually were to invest in such technologies, you can actually quickly recoup your entire investment in CapEx by the savings that you get on the operational side. And if you actually do it quite well, you can actually maybe get $2 back for every dollar that you spend. So that is a big problem. That is, massive untapped value that can be recouped. Why is the time now? Well, 10 years ago, the problem, first of all, didn't exist in the same level of intensity across the board. 10 years ago, or maybe even more than that, you had the first cloud companies that were emerging. Google, I know JR was there, and then Facebook, etc. And it was very clear to them, right, that in order for them to build the networks that they needed and to operate them at scale, they just couldn't use the vendor equipment that existed at the time. And I was there, I witnessed it when I was at Arista. And they, because they knew it was existential for them, put tremendous pressure on the vendors to change the paradigm. Essentially, we had vertically integrated systems. We didn't have APIs. And what they needed were the APIs. They needed programmable infrastructure in order for them to be able to build the automation on top to essentially massively streamline the operations of their data centers. So they were essentially the early adopters, and they pushed the vendor community. And because these markets, this market was a really large one, they got the attention of the vendors. And so fast forward now 10 years plus, finally, and it took a long time, everyone from the incumbents to the newcomers, they have APIs. We now have a programmable infrastructure. We effectively have a disaggregated infrastructure where you have, I call it a horizontally layered architecture as opposed to a vertically integrated architecture where various companies can essentially contribute at these different, innovate at these different layers, provide best-of-breed solutions at these different layers. And so for a company like us to exist, we needed that. And so we can focus on our layer, which is essentially the operational layer. And so why is it that we think we're the right team to deliver on this? Well, first of all, just in terms of our backgrounds, we've been in networking all of our careers. We've seen the trends. In terms of the ingredients, the technological ingredients you need to build our layers, our solution, we need expertise in distributed systems. Networks are distributed systems. We need to scale to the largest data centers. There is no other way than to actually build a distributed system. We need abstractions, and we have deep experience as a team in network abstractions. And we have built, and we've been part of many trends. We've seized opportunities along the way to build businesses that delivered on the opportunities for these trends. And we are also privately funded, which I find useful, especially in the early days when you really need to focus on building the architecture, building the foundation for the ambitious kind of program that you have. And so we're privately funded, and just as such, we have that advantage as well. So 3 years in, we just celebrated our 3-year anniversary this last Friday. It's been an awesome journey. We're still at the early stages of the journey. We're very pleased that Gartner recognized the company. We were named Cool Vendor in a report last week. They also recognized the category. They called it intent-based networking systems, essentially based on our product. And these are just a few quotes from these reports. I encourage you to go to our website. You can essentially get these reports. You can also get a lot more information, read our blogs, and please feel free to get in touch with us if you're interested in learning more. And certainly, I expect in this panel discussion, I'm happy to answer other questions as they come up. Thank you.
All right. Thank you, Mansour. Excellent. Well, we'll get started. So the way we're going to run this is we're going to have each panelist introduce themselves, and Mansour, you can introduce yourself again if you want to. Probably yeah. But we're going to have each of them introduce themselves, spend a couple of minutes about who you are, your background, and why you're uniquely qualified to do what you're doing right now, based on what Mansour's slide said. So let's start with that. I have a couple of questions to kick us off. And at about 8 p.m., sorry, 8 a.m. About 8 p.m. It's a long day. About 8 p.m., I will take questions from the audience. So I think this, yeah. So as you're listening to them talk and questions come in your mind, feel free to go ahead and text the questions. And I'm going to check connectivity. I think I'm having a bit of connectivity problems, but I should be able to get questions here, and then we'll ask your questions to the panel, starting at 8 p.m. So please have questions. Otherwise, it's going to be a very short night. Right? So, all you're going to hear is just me droning on and on and on. So you don't want that, believe me. All right, let's start with JR. Why don't you introduce yourself as JR?
Hi. Is this thing on?
Yeah, it is.
All right. I'm JR Rivers. I'm co-founder and currently CTO of Cumulus Networks. I had the glorious honor of being the CEO for the first 6 years of the company, which is great, uniquely allows me to speak about both the technical and the business aspects of starting a business in this space. Cumulus Networks was, why am I uniquely qualified? I was a Cisco fellow. I worked at Cisco for about 16 years. I was responsible for the pizza box switching business for about 12 years. From the technical side, I was a distinguished engineer. It was about a $6.5 billion business when I left in 2005. I went to Google and spent a bit of time there as they started building their own network infrastructure. So that gave me a really great both lens as well as execution-oriented perspective on building high-scale data centers, both from a why you build it and how you build it kind of viewpoint. And then I ended up back at Cisco as I was the system architect for Cisco UCS. It was Cisco's perspective of what they now call converged infrastructure, integrating compute, storage, and networking into one single point of management or single management framework. During that whole journey, I became acutely aware of the fact that the scale of computational power and the amount of interconnect necessary to pull that off was occurring at a rate that would never be matched by incumbent networking suppliers. Part of it, the incumbents have phenomenal technology. They've got great engineers. Their business models are a little bit warped in that they're, inevitably when you look at a server today, I can take a really cheap server from Dell or anybody, and I can pump 25 gig through a server today, which is amazing. I'm currently network limited by the cost of what it takes me to deliver network capacity. When I was at Google, my boss, Stephen Stewart, laid it out in a super simple way, which I'll let you all kind of saturate your brains with, which is, look, it cost me $1,500 to buy a server. I need to build a cluster of 10,000 servers with full bisection bandwidth at $150 per server for the whole network. So when you look at IT technology, specifically around computer science, inevitably price performance matters. And we recognized when we started Cumulus Networks that there was no way the incumbent vendors were going to get to a price-performance ratio that made modern businesses make sense. How do you build networks for applications you can't even imagine right now when the current applications are throttled by network capacity? So that's me. That's why I'm uniquely qualified. Cumulus Networks is currently focused on providing phenomenal disaggregated network operating systems. We effectively created this genre in this industry and built the ecosystem around disaggregated networking hardware. We offer a Linux distribution, Cumulus Linux, which uses the Linux networking model as a pervasive data center-focused networking model that you can use on switches, routers, and on hosts. And then we have other aspirations in other parts of data center operations. As Mansour is pointing out, that's kind of a weak spot in the chain today. Thank you.
Yeah, excellent. Thank you, JR. And very good. Yeah, when I first met JR, it was kind of interesting in talking about sort of Linux and networking. I met him, and he's like, Roy, look at this. And those of you who understand Unix or Linux will appreciate it. It types ifconfig, and all the network ports show up right on the command line, right, as if it was a port on the server. And that's when I'm like, oh, that's interesting. Right? I remember that.
Well, in fairness, I showed you that, and I guess this is a juxtaposition which you may or may not get today. But if you're a data center admin, 10 years ago, you were either a networking person or a sysadmin. In a modern web-scale IT infrastructure, you literally are an infrastructure admin. You're on the hook for the physical infrastructure. So when you sit down on a platform, if you have some weird connectivity issue between a host and the network, you're going to log on to the host and the network, and you're going to try and figure out what's going on. If you, in context of web-scale IT, the hosts are predominantly Linux, Linux-based or use Linux operating systems. You can type ifconfig on that platform and understand what's going on. In the old days, you would log on to a switch and type, show blah blah blah, and you would get something that looked totally different. And when you look at those two things on exactly the same screen, it's jarring. It's really, really hard to diagnose, to configure, to work. And so creating homogeneity or a common operating perspective that spans servers, storage, and networking is phenomenally important to create scale in a way that people can understand and manage.
Good point. Thank you, JR. All right, Amit, go ahead.
Thank you, Roy. My name is Amit Sanyal. I am VP of Product Management and Marketing at a startup called Innovium. Innovium is a fabless semiconductor company that is developing game-changing Ethernet switch silicon that is exclusively targeted at the data center. A little bit of my background, I think over the last 20 years, I've focused exclusively on the data center, and I've had the privilege of working on server, storage, and networking. Before joining Innovium, I came from Dell. I spent about 5 years there, focused on data center networking and software-defined networking. As part of that role, I kickstarted and initiated the open networking, which was all about disaggregation. And there I partnered with both of these people here in kind of evolving that solution. Prior to Dell, I was with Cisco. I spent 11 years at Cisco with various data center products. One of them was the UCS server with Jeff, JR. And in addition to the servers, I also focused on the switching as well. And prior to that, I spent time at Sun. So I'm very excited to come to this side at the Menlo Park. I haven't come here in a long time. And I'm really excited to be part of this panel. A little bit about our company, Innovium, because most of you, I suspect, don't know about Innovium. We just came out of stealth. As you know, today, cloud is changing the IT landscape, right? Whether it's enterprises, whether it's cloud providers, they're investing heavily in large data centers. So we saw this as an opportunity. We went and spoke to them about their problems, about what they needed. We found that, as JR said, companies like Google and Amazon and others, and even broader data center customers, the bandwidth was just exploding. Every 12 to 15 months, their bandwidth was doubling. Right? In addition to bandwidth, they also had other pressing needs. And we found that the networking solutions that they were using was general purpose networking switch solutions that they had kind of repurposed for the data center. So that was a huge opportunity for us to tailor our solutions for the needs of the data center. So the founding team came out of, the Innovium team came out of two companies, Broadcom, where they had done generations of switches, and Cavium, that was the founding team. We just launched, we've been in business for just over 2 years now. We just launched our first product. It's called Terralinks. Terralinks is the world's fastest, most scalable switch silicon that has industry-leading analytics, line range programmability, as well as power efficiency. In essence, if you just look at the high level, we are the world's first 12.8 terabit switch. Today, switches that are being deployed are 3.2 terabit, and you will expect sometime soon from other vendors 6.4. So it's clearly a game changer. In addition to that, we provide twice the amount of buffers that enables higher quality networks. We have 2x power efficiency, and we have a lot of analytics. And overall, it gives customers that are deploying large data centers between 6 and 12x advantage over existing solutions that are out there. And so we are getting a lot of interest from the large data center operators. We're really excited. And that's kind of the summary of what Innovium does. And look forward to engaging with you guys in the panel.
Thank you, Amit. Thank you very much. All right, Sudip, why don't you go ahead?
Sure. So hi, everyone. I'm Sudip Chakrabarti. I'm a partner at LightSpeed Venture Partners. So while these guys are changing the world, my job is to get out of the way, really. So for those of you who don't know LightSpeed, we're an early stage venture firm based out of Menlo Park. We have been around for about 15 years. And currently we are investing out of our 11th fund, raised last year, $1.2 billion from this fund. We invest in 3 areas primarily, mostly software with a little bit of hardware as well. Enterprise SaaS, enterprise infrastructure, and then consumer. We are primarily early stage, so we do seed, Series A and Series Bs, and an occasional Series C once in a while. Some of our portfolio companies, I'll just note a couple that have been in the news recently. So we were seed investors on the consumer side in Snapchat, Series A investors in Nutanix and AppDynamics, Series B in MuleSoft. Some of the other companies, we are investors in Docker, DataStax, Mapper. So a lot of companies around enterprise infrastructure, open source, B2B, and of course, we have a consumer practice, which I'm not allowed to get close to. So in the networking space specifically, we were an early investor in Nicira back in the day. We are the largest shareholder in Barefoot, SnapRoute, companies in this space. A little bit about myself. So I focus on enterprise infrastructure. So I've been in venture about 5 years. Before coming to LightSpeed, I was at Anderson Horowitz, focusing on the same areas. In fact, got a chance to work with Jared a little bit. And then my background is engineer, trained as an engineer, been through a couple of startups. I primarily focus on what I would call technology differentiated businesses. So, another way of saying I'm very geeky. And tend to work a lot with companies coming out of the open source ecosystem, university spin-outs, engineers coming out of large or small companies. Because without the core technical founders, there's no company in my mind. So I tend to really focus on those kind of opportunities. So yeah, that's pretty much about LightSpeed and me, myself.
Okay, excellent. Thank you, Sudip. All right, so let's get started. Ask a couple questions here. Yeah, good. Looks like I can see the spreadsheet. So I think, as the questions come in, we'll see it. All right, let's jump right in. One of the questions here is, so we've seen CPU, virtualization, all that evolution, and all those innovations. The question here is, has networking evolution been slower than storage and CPU? And if so, what's different today? Is networking all of a sudden more important? And maybe address the question to Amit first, given that you've worked in CPU, storage, and networking, right?
A very good question, actually. If you look at any data center and take a server, which is the building block of a data center, and look at the storage, CPU, and networking on that server, over the span of, say, last 15 years or so, because of transition of hard disk to flash and then soon NVMe, the IOPS and latencies have gone up 1000x, 50x respectively. If you look at CPU, Moore's law has helped drive over the last 15 years, every 18 months to 24 months, it has doubled. And again, it has gone up, I would say 70, 80, 100 times. Whereas on the NIC, on the networking front, if you look over the last 15 years, it's gone only from gig to 10 gig. And just now, the transition has begun for 25 gig and 50 gig. And those are being deployed by the large cloud guys. So clearly, it's been a little bit behind. But when you look at the large data center operators, as JR mentioned, whether it's Google or others, they are seeing bandwidth for the network, the bisectional bandwidth, that grew significantly. And interestingly enough, they don't want these expensive resources, compute or storage, to be lying idle, underutilized because of network coming in the way. Right? If you look at, and I think that is one of the things that people are now beginning to push and hence investing more in networking. That is one of the reasons. And clearly from a workload perspective and others, if you look at various drivers of growth of traffic, right? First, there is storage. Storage is moving from fiber channel to Ethernet based, more distributed using Ethernet. So that's storage moving over the Ethernet pipe. There is application architectures are changing, and that is putting more pressure on the networks. People are writing, instead of monolithic apps, they're writing more distributed apps using microservices. So there's a lot of east-west I/O that is happening. Look at artificial intelligence, machine learning, and so on. So that, look at the kind of rich media, whether it's video and others. So all of this is driving a lot of I/O. And hence, going forward, I do expect that even though it has lagged, from a creation of the network, these large operators want to make sure that the networks don't come in the way. And typically, the spend of a network in a large data center varies somewhere in the 10-15% range. So they don't want 85%, 90% of their spend lying underutilized, and hence they are paying a lot of attention. And you can hear that publicly from likes of Amit or others, from Google, AWS, and others. As a result, I think going forward, there's a lot of emphasis on making sure that networking bottleneck isn't there. And that is one of the genesis of why Innovium exists today.
So I'm going to take a slightly different cut at what Amit was saying. Networks actually virtualized long before storage or compute. So I remember back in like very early 90s, we had virtual LANs, and Dell had this like super cool thing where they would spin up your company's network on their production line, 4 different facilities, all using automated VLANs, and prove that everything kind of worked out right. So the networks were virtualized long before compute and storage. To Amit's point, the problem is the price performance of network capacity didn't track that of compute and storage. I did a study like a couple of years ago where I went back and looked at historical trends around kind of the cost per gigabit or gigahertz of compute, the cost per gigabyte of storage, and the cost per gigahertz of networking, and I graphed it out in a log graph. And interestingly enough, storage and compute tracked each other. One is Moore's law. So physics don't add up. Moore's law is silicon, but storage, even with spinning disk for the most part, was tracking it. Networking was reasonably flat, and that was kind of caused by the way the ecosystem around networking had grown up. What we've noticed it's probably about 10 years ago now, 50, maybe, gosh, Jesus, I'm getting old. About 12 years or so ago, Google woke up and said, hey, you know what? For us to build the applications we want, we need network capacity to kind of track Amdahl's second law. How many people, I can't really see you all, how many remember Amdahl's second law? All right, all the old dudes in the front with me. All right. So it's actually super important, and it's something that you should have in your mind because it defines the spirit of web scale IT. And the law is for every 2 hertz of compute capacity you need to have a hertz of storage capacity and a hertz of I/O capacity, or hertz of memory basically and hertz of I/O. And when you have, that is what the definition of a balanced compute system is. And when you go back and look at trends over time, what you look is the industry constantly chasing that law, even though only graybeards remember that it exists. And that's kind of where we're at right now. So kind of circling back to your question, the virtualization of networking has existed for a long time. The capacity of the network has not tracked appropriately, whereas it did on the compute side. We're starting to see that whole trend, disrupt itself. Part of what has to happen is the hardware supply chain has to look like the right hardware supply chain. The software supply chain has to look like the right software supply chain so that you get the price performance that you want. But in terms of network virtualization, it's incredibly rich these days. I mean, if you want to go nuts on this, I can walk you through every situation where network virtualization exists, it's mature, it's being deployed at scale in a bunch of different environments that don't include Nicira or VMware.
So I think the premise here is that, okay, so I think Amit very rightly pointed out that the why now, right? Because the changing architectures of applications, the new demands and all that. So it's got to be now. And I think, so JR, your premise is that it's because of lack of disaggregation where that networking has been held back. The incumbents who are not represented here today, unfortunately, tonight, I'll pretend to be Cisco, but,
I got to see it.
all you need is a Cisco 7000. I date myself, see? But anyway, but is that true? And if so, why is it that the networking incumbents have held so much power for so long when compute and storage fell some time ago? Right? What is it? What's driving?
If you guys mind if I?
Sure. No.
So, sorry, I don't want to dominate. But so the issue is the same one that Google encountered, which is if the network looks like X.
Right.
So when I look at a computer, right, if I write algorithm Y,
right,
if I get a faster computer, Y goes faster. Wow, that's scale of 1.
Yep.
I can affect my world in scale of 1. If I have a network that is structured in a certain fashion and I write an application against that network, I'm going to write my application to understand the limitations of that network. And I am not going to imagine an application that would work on a better network because that doesn't exist for me. So when I was at Google, search had all these crazy ass locality things built into it. Like if I'm local to a rack, I'm going to do these things. If I have to go across a rack to get data, I'm going to do this other thing. It was built into the application because that was the network that they could build. And the company realized we can't do that. We need 10,000 servers, whole bisection bandwidth, so we can write applications don't understand locality in units less than 10,000.
So it was a mental block?
No, it was an enabler. Like literally Larry Sergey woke up and said, "We need this. Stephen, go make it happen."
Right.
What
I'm trying to figure out is why it didn't happen earlier. Right?
So I think
Why
one of the reasons to tag along with what JR said is the cloud companies emerge or the web companies emerge over the last 10 years.
Right.
They were the biggest, started becoming the biggest consumers, biggest influencers. And they realized that as they did things that needed to scale, networking became the choking point. They had the buying power, they had the expertise, they could design things on their own. They put together things from various components and designed architectures that could scale better.
So the market economics is part of it.
Yes, and today they influence the dynamics of the market in a significant way.
But
It's expanding beyond that.
I'm going to take what you said to kind of add on it. It's not that the incumbents couldn't build those same architectures. The incumbents weren't willing to build a business around those same architectures because there was a price, performance, capacity set of trade-offs that just wasn't interesting. There's this kind of classic perspective I get asked all the time at Cumulus. We help drive down the aggregate cost of someone running a network, both CapEx and OpEx.
Yep.
And everybody says, wow, smaller market.
Yep, that's what I was going to ask next.
Right, okay, so I'm going to jump you here. If you go back and look at compute, it's exactly, I'm going to cry bullshit, if you don't mind me cussing a little bit. But, the history shows us in the context of IT that that doesn't happen. The spend either stays flat or increases But what happens is you see a or a ramp in capacity, and that capacity is what enables new business models.
Okay. Sudip, you want to add something?
I just want to add one thing. I mean, to your why now point, right? We obviously I think there's a bottom-up way of looking at things, and there's a top-down way of looking at things.
Sure.
And if you look at the scale in the web scale, I mean, what Amit was saying, like kind of need to process a lot more data, a lot more compute, it's like the scale is very different from what it was 10 years back, right? And it's no longer just limited to the 3-4 web scale companies. Even like I would say, some of the mid-market companies are feeling that pain. So the way we kind of look at networking, and we kind of see like a lot of activities around that. And our primary reason is there's a lot of Amit touched on this, which is like the disaggregation of applications, right? And the way people designed applications before is changing very rapidly. And today, your application is no longer a block of code, sitting on a single server or a VM. It's a collection of services. And what is the limiting factor, when it comes to performance there? It's the network. It's the east-west traffic, how fast can they go? Could you secure those applications when it's just a conglomeration of services? So I think that why now is very important, because you see some of these companies kind of doing this kind of applications 4 or 5 years back, and now you see even a tiny startup we found today, from day one, they're thinking about like how do we design this application so that it can scale. And oftentimes, the services they are calling, they will probably never develop themselves. They are calling someone else's API, someone else's services. And it's very important to understand the role of networking there, actually.
No, thank you. So one of the things we keep talking about is sort of web scale, right? The biggest of the big driving everything. And what we didn't talk about is enterprises are moving a lot of workloads to public clouds in many, many, many ways. So at the end of the day, if we take this and we project out 5-10 years, does that mean that the only people who care about networking are public clouds?
No. What we're seeing is actually a slight variation of what you said. When we look at large enterprises, we see them starting to make very, very conscious choices in 3 directions. One of them is public cloud. Typically, we see them going to public cloud for things that are incredibly elastic, i.e., I need 1,000 things this month and I will never need them again, or onesie-twosie things, right? I have this little tiny thing, I'm just going to go off and run it. Before I would have bought 3 servers and had some IT person stand them up. I'm just going to get 6 VMs in AWS or whatever. Yep. The second direction that we see people heading is SaaS, and this is an underappreciated perspective. The first big step there was Salesforce, where people, imagine this, you take your sales database, the most prized possession of any enterprise company, and you give it to somebody that has everybody else in the world's sales database. Wow, this is like not smart, but people did that a while ago, and they're continuing to do it. So HR, a bunch of financial services are all moving off into SaaS operations. And then the last piece is what's left over are compute requirements that are key to your business. And consistently over and over again, we see people building private clouds for 2 fundamental reasons. One is Amazon is really, really, really expensive. If you have a consistent workload.
Give it 24/7, by the whole month.
Yeah, if you're running a reasonably consistent workload, or even let's say a 50% capacity workload, it's way cheaper to build it yourself, or Amazon is your competitor. So there's a bunch of companies that we're working with right now that actually were taking their workloads to AWS, and they woke up one morning and said, "Wait a minute, my biggest competitor is Amazon, and I'm funding their infrastructure by me putting my stuff." And I'm giving them all my data.
Well, there's Microsoft Azure. there's Google Cloud. There's Rackspace.
Yeah, but as well as I do that AWS dominates everybody in the States, right?
No, we use AWS.
Yeah, not just you, but I think it's like 80% right now of all workloads are in AWS.
Right.
But anyways, those are the 3 places that we see people going. So it's not all going to public compute. It's going to hosted environments, not just AWS, but there's DigitalOcean is doing great. The DreamHost. There's a lot of these small hosters are doing really well. SaaS companies, and then private clouds.
I'm going to agree with a lot of what JR says.
Agree with that?
Yeah, we see a lot. We do see that many enterprises are building their own private clouds for their critical assets. I think I just wanted to add one reason. Which is relevant in many businesses, and it is latency. And there's this new trend with edge computing, right?
Yes, that's correct.
right?
Mobile edge compute.
Yeah, which with IoT, it's really critical, and the latency factor becomes really important, and for that reason, you need to be really in control of your data centers, and so it's the expense, right? It's like renting a car to commute every day,
Yep.
right? It's the fact that these are critical assets and you need to be competitive, and therefore you need your infrastructure, and then latency.
That's good. So if you rent a car, that's IaaS, and then if you do Uber, is that like Lambda? I don't know. But it's a bad joke. Sorry, it's a very, very geeky joke. We'll ignore that. We'll move right along.
Can I make a quick point? So, sometime back, we actually did a study of like when it actually makes sense for companies to bring back their compute from AWS to in-house. So it was pretty interesting. It was actually not a big number, honestly.
I'm going to guess probably in the no more than 20 computer range.
I don't know. It was more like a few hundred thousand, like
few hundred thousand computers?
Dollars.
Dollars,
dollars.
Yeah.
So we had
about 20 computers, right. Yeah.
So it was actually surprisingly low. But I think one thing I would say, because what we are seeing a lot of interest in these days, that I see as a threat, which is contrary to that, which is public cloud providers realize that if your workload is somewhat ephemeral, like you're, let's say you have a car calling in or a thing calling in every few minutes, standing a VM or a container for 24/7 can really incur you a lot of cost. So they have gone this way of Lambda, right? AWS Lambda or serverless. And I think that is a very interesting paradigm where the compute is all you're buying. You just upload the code to Lambda and you basically kind of let them, you call the function when you need, and they charge you only when you're actually using that compute. So that changes that equation quite a bit, the pricing equation. That's what we're seeing.
I mean, it could. But we're going to pull it back a little bit. And what Lambda does is actually use more networking.
Yeah. I'm not suggesting that. I think actually, in my view, networking is so interesting because it's getting more complex to control and manage because you have cloud, hybrid, on-prem, and because of all the east-west stuff we are talking about. But all I'm saying is like the cost equation is changing a bit. That's what we are saying.
Right.
Yeah, and I think you're clearly correct. And I think the piece that I always look at there is kind of back to this scale of X thing. And so if you're a company and you used a car as an example, that's a lot of calls back. I'm pretty sure I'd find that if I'm a car company, it's better for me to have a few distributed data centers. It'll be cheaper. Mm-hmm. If I don't have that much telemetry, if it's a little bit less, it's going to be way more cost effective. Not just from a CapEx, but the OpEx, what it takes to run, the setup, all of the pieces around it. So it really gets down to the scale of your business and how much of it's dependent on that overall compute.
That's because you haven't used the Amazon Mac infrastructure yet. They're building it right now. I wouldn't be surprised. Right? So, but maybe let's bring it back for a second now. So we're actually at 8 o'clock now. I'm not seeing any questions, but I'm going to ask very quickly. Sudip, is it true that there's no questions from the audience? Because I'll just keep going. Oh, sorry I asked that. All right, I have 8 questions.
Oops.
It's network connectivity. Network issues you're having.
It's on demand.
You need a Cumulus switch.
Yeah, it's like
no, if it was Cumulus, it'd already be here. That went to AWS, man.
This is just like intent-driven questioning. All right. I don't know. It just happened. I didn't even, I don't know. All right. Let's see. This is a good one. Whoever asked it. Smart question. Should disaggregation software be open source or closed and enterprise grade? So I think there's sort of a couple of things in here. If I was Cisco, I'd be asking that too. So should it be open source or closed and enterprise grade? Right? That was a loaded, but maybe anyone would take that. So what do you think? Does disaggregation mean open source? Right.
Well, maybe I can start. Yeah. I know that there's a lot of discussion about open source, but I think that if you look at it from an organization standpoint, qualifying suppliers is not a new thing, right? Organizations have been have processes to qualify their suppliers for hundreds of years, I would say. And I think that when you're bringing in a supplier, you're really depending on them, right? And so when you're qualifying a supplier, usually the questions that are asked are you want to know that the supplier is going to stay there for a while, right? It's going to be able to support you, right?
Yeah, how big a check can David Cheriton write? For example.
Right. Well,
Probably very big.
Right.
You keep going. Sorry.
Yeah, sure. You want to know that they're going to be there in business. You want to understand what quality standards they had,
Yep.
right? And so, and you want to know if they are meeting your requirements, your specific requirements as a business.
Right.
So I think these are the initial set of questions, and then they want to know that, for example, they can be flexible. They can maybe modify something in there without really waiting for the vendor, right, to decide that this is something that they want to deliver as a requirement for the rest of the market. Right. They want to be able to maybe, certainly as part of the disaggregated infrastructure, they want to know that, well, I can stitch this into my infrastructure. I have the right APIs, right? And so, things like extensibility and APIs become really important. And so, I think these are, some of the main considerations.
What I'm hearing you say is that, look at the business requirements for validating a vendor, right? And understand what the business requirements are. Open source doesn't necessarily have. If open source turns out to be the right answer, it's because open source brings with it attributes that are relevant to those business questions, as opposed to turn it around and say, is it open source?
Well, exactly. We don't see that, right? Essentially, the procurement goes through, well, what are these? And then I think the last one is risk mitigation, right? If the vendor were to go out of business,
what happens?
We put your code in escrow, stuff like that, where like essentially you have a plan B, right? Sure. And so I think this is the way procurement thinks about these things. Yep. And so exactly to your point, that's it's kind of I'm turning.
I like that answer because if Cisco was sitting here, they would give that answer to a certain extent, even though there's different parts of Cisco, right? Because
so I would say based on my experience with customers, I think whether they pick open source or not, the first thing they want is a solution which is stable, which is the company is reliable, economics is right. There are other criteria before they get into whether it's open source or closed source. And one of the things that depending on, again, the segment of the customer, right? If a lot of the smaller customers, they want one vendor throat to choke. Correct. They want support, services, everything from one. And that is where an incumbent like Cisco and others benefit. Right? Because they can provide that, or even
any supplier will need to do that. If you're a supplier,
I think that is for the smaller customers. If you look at SMB or maybe smaller enterprises. The big cloud guys, they want, they have large amount of engineers, they have resources, they completely go disaggregated, they can go open source, they can support it. So that's different. And I think enterprises, mid-sized companies, they are in the middle where I think they are figuring out what is the right model. Should they be disaggregated and get from different sources or not?
Sure.
Based on, again, the economics and other value that
I think that's fair. So Sudip, you had a point?
Yeah. I agree with what you're saying, and I think what Mansour is saying. But I would probably go out on a limb and make a statement that, just to make it interesting. If you're, as an entrepreneur, if you are planning to build an infrastructure business, infrastructure company, kind of focused on the next generation infrastructure, open source must be a big component of your business. I mean, it has to be.
I'll tell disagrees. No, I'm kidding.
Yeah, vehemently disagrees, I'm sure. I'm sure he disagrees. I'm just kidding. No. But I'll tell you why. Yeah, why? I'll tell you why. Why? Yeah. Right. So, it's like, first of all, the reason you open source is you basically create a fantastic technology, a core technology probably, and then you basically are trying to figure out what the product should look like, what the use cases should look like. How do you test the market? Like, how do you know, why people should use it? What are the use cases? So the only way, and it's a very efficient way, by the way, is to go and put out in the open source world and see how people are using it, why they are using it. Because what you really want out of that is, a Google or a Facebook or, one of those lighthouse customers to stand up on this stage. They'll probably never pay you $1, but tell the world, hey, we are using this particular open source technology for our entire data center networking. And think about the enterprises that kind of follow Google and want to be Google in 5, 6, 7 years, and they look at this particular technology and tell themselves, hey, if it's good for Google, it's good for us. So then the opportunity is for you to go and build a product around that core technology. And as an infrastructure investor, like that is a big part of our core belief. So we have backed like over a dozen open source companies in the last 5 years, and I just, I take an extra careful or cautious look when there's not an open source strategy. There might be a very good reason why there is not, but it's like it's almost a starting point in this next generation container, kind of serverless ecosystem.
Is it because networking is hard?
I'm saying that again?
Is it because networking is hard? That's why there's less open source.
Or it could be like critical. I mean, you should.
I would aggregate what everybody's saying in that there's a couple things to keep in mind. Networking has to work. People don't like to hear this, but like when
But not compute well.
No, actually, you're right. It's not compute. Like, here's the deal.
Yeah, correct.
I can go buy the really coolest new storage solution, and all of my peers in my IT department can look at me and say, JR, you're an idiot. That crap is going to break. And I can be so cool, and I can buy it and stick it in the corner. And if my app breaks, I die. Everybody else is cool.
Correct.
If I'm the network architect and I build the network that runs the whole company business and I'm wrong, off with my head. Really simple. Networking has to work.
Right.
And so kind of back to your point, enterprise grade has a lot of connotations. Must work has to be in there, right? And
that's table stakes.
Pardon?
That's table stakes.
But it's got nothing to do with open source.
Actually, you say that, but as you know, there's a lot of companies that go out there with a lot of open source, and people get fired up around it, and it sounds great on paper, and then what you find out a couple of months later is it didn't work, and like all that noise and hoopla really was noise.
So open source is a marketing and market distribution strategy.
Well, what I'm getting at is, we're kind of circling back to the open source thing is, I don't look at open source as an end, it's a means, right?
Right.
If you have a piece of technology that benefits a community, or you want to participate in a pre-existing community that's open, it's a great thing to do. You get FTE aggregation, you get mind share, you get to share new ideas, as Sudip was pointing out, where you get to kind of test markets in that space. I don't think you wake up in the morning and say, okay, you got to be open source. You do it because there's a great reason to do it.
Yep.
And then you deliver technology that works well.
And I would 100% agree.
I would say one thing though, that historically, if you look at the evolution, open source in the networking space has not been very successful. There have been companies, but their level of support has grown up and down. They've retracted. We, I think, as an industry, would benefit from a Red Hat-like open source networking solution, but that hasn't happened. I mean, so far, I think
because you got to pay people.
Right. So I think
free software doesn't feed the family.
Right now, if you look at the landscape, I think Microsoft's effort of Sonic is somewhat promising, but we'll have to see where it goes.
I mean, I think if you look at L2.
Okay, now we're going to be controversial. Microsoft's Sonic is the laughing joke in the web scale data center world.
So again, we'll have to see. Right?
You know what? But actually, you know what? Let's stay with that for a little bit because. So, I mean, those of you maybe not familiar, so Microsoft did a big announcement of Sonic, right, which is basically
2 years ago.
2 years ago, which is networking OS, and then recently.
How many servers are running? How many systems are running?
It's
with
very
that right
limited.
now? 2 years. 2 years
I
later.
mean, it's still early days.
Networking is hard.
All I can tell you is one of the top 4 is using our stuff, and it took us 6 months from engagement to production, and they've been doing that for 6 years now.
But you're correct. I mean, we don't see any we don't see any strong layer 2, layer 3 stack. For instance, I mean, look at layer 3. Look at Quagga. Look at Zob, which I was involved in. Sad to say, but you look at I mean, they're not very good stacks out there.
That's not actually. I'm going to take offense to that.
Go ahead.
Quagga is not free range routing, which is all the people that worked on Quagga
coming
and
together.
aggregated their stuff.
New project, Linux Foundation, by the way. So
yeah, Linux Foundation. Like you use that every day. Everybody in this room uses that every day.
But is it
every day?
Grade?
What?
Carrier grade yet, or
define carrier grade? Like, are there carriers using it at scale?
Probably
yeah,
not yet.
Probably at least half the people's cell phone uses this.
Wow.
Right. So, yeah.
So maybe it's happening.
But I think
without us knowing, it's happened.
The key thing is there is no company that would stand behind that open source today, right? You would have to buy, you would buy software from a commercial vendor. It's not like there is only a service like a Red Hat or on Canonical. That equivalent is probably you guys are the closest.
Yeah.
But I think what JR said, which is very important, it's a means, it's not the end, right? And that's what I think when you really look at the way infrastructure is going, at least what we believe is like it's a very critical means. I mean, we really like think that's a strategy that often works to get the market tested, to find the product market fit. At the end of the day, you obviously have to deliver something that works. I mean, without that, there's no business.
One thing that he said, which is very important, a server goes down, bunch of VMs or some things running on that server goes down. Network goes down, the entire rack or maybe the entire data center goes out. So there is a big difference, and network has to work, and that is, I think, part of the reason why it's mission critical.
Yep, no, fair enough. Okay, I'm going to move on to the next question so that we get a couple here. This is an interesting one. I'll ask, I'll actually ask this one last maybe. So if networking is really the limiting factor in network performance growth, and there's a tons of need to overcome, so what are the top cost drivers that need to be overcome, right? Is it optical components, silicon, power, switching, proprietary architectures? Who's disrupting any of these elements within networking, and how?
These guys, Innovium, like silicon, like switch silicon is a huge space. We don't have any optical people, but optical is actually a huge piece. But what these guys are doing is it's a huge push forward.
Yep. So that low-cost optics. Yep.
So I think one of the things is, if you look at the large data center, right, they have a need for building these terabit kind of networks, petabit networks, where they need switch silicon to have large radix. Economics being right. Cost per bit is something that everybody pays attention to. So the cost per bit, as JR said, needs to come down, right? And cost per bit comes together with the merchant silicon, the optics. So the two together drives the cost structure, and that then drives the overall cost. And that's the CapEx. And clearly there is an operation layer which comes on top as well.
Correct.
So the total economics is because of CapEx and OpEx.
Just touching upon, we talked about operation expenses and $3 to $5 for every dollar of CapEx. Exactly. So I think that is a major cost center, and as networks grow, it becomes even increasingly more important. And we didn't even touch upon the opportunity cost and like, let's say, cost of outages, right? And what is the number one cause of outage? Humans.
Human configuration. Misconfiguration.
Humans touching
fat fingers,
somewhere, right? And so, how much does an outage cost in enterprise, right? How much does it tarnish their reputation? How much lost revenue, right? So I think that and this is essentially what we're living and breathing, of course, but it is a very critical aspect that needs attention.
So kill humans.
Can I just put in a plug for Mansour? I think one thing that's pretty interesting is if you go back 15 years and look at the control span or span of control. So what I mean by that is for a sysadmin, the number of servers a particular human being controls. If you go back 15 years on the compute side, I think I saw some numbers where it has increased like 33 times in the last 15 years. On the networking side, like 1.5 times. And think of the cost and the OpEx impact for that. It's pretty dramatic, actually.
And tying this all the way back to the kind of topic, disaggregating the data center, at the most fundamental or visceral layer, separating the software and operational aspects from the hardware performance aspects, super important. It allows because as you can imagine, if I have, I build a data center, I've got 10,000 links in my data center between point A and point B, or point 10,000 different A's and B's. If the speed of those links go from 1 gigabit per second to 100 gigabits per second, I expect to see that change manifest as hardware expense. My control plane, my OS expenses, my operational expenses should scale flat for that. Right now, if my capacity increases, like I add more links, I expect, And so what disaggregation does is it actually allows that to occur. If you look at incumbent spaces, no matter which incumbent you look at and how you look at it, it doesn't square up. What happens is if I go from 1 gig to 10 gig to 25 gig to 100 gig, I go up both in hardware cost as well as associated software and support cost.
And is that because of a profit model? Is that, and you're saying that's not inherent? And that's not necessary?
It's not physics.
It's not physics. So Cisco's when he tells us that physics is not true. That's what you're
Hey
saying.
man, I was there for 16 years. I made sure it wasn't physics.
All right, that's good. Let's keep moving. Well, the physical locations of data centers will disaggregate. I think we talked about that a little bit in a sense with mobile edge, but I think this question goes a little further. Will we go from relatively few data centers to a larger number of smaller data centers? Will we see that trend, that shift?
100%.
I think there are a number of factors that will impact that. Clearly, if you have large data centers, the scale of 50, 70, 100,000 servers, economics are better.
Right.
However, there are other factors like geopolitical factors. There are factors where politics comes in. There are laws in countries where you have to have the data in that country, so you would then obviously have the distributed applications, distributed data centers, then latency, a bunch of factors, and I think those would influence how they are done.
And I would say, I strongly believe in that, and I think, we talk about this thing like diffuse data centers, which I think, it sounds a lot.
Fog computing.
Yeah, and you can,
distributed cloud.
edge computing, whatever you want to call, but it just, naturally, like, some of the use cases that are popping up, more and more. I think Mansour pointed out like 50 billion devices connected. A lot of those use cases will probably not have the luxury to go back to the data center and come back from, just from a user experience, safety, criticality standpoint. So you have to have, kind of much more, kind of edge computing, and whether there will be data centers like in closets or actually running on your phone, like much more powerful computer in the car, I don't know, but definitely you can see that happening. You can see some of the stack, kind of going that way.
And what's the opportunity there, right? So if the entrepreneurs hear people thinking about it, that's pretty cool. That's a shift in topology, shift in architecture, shift in economics, right? What do you think the opportunity is there? What?
Well, when I look at data centers and how it transitions, what I've noticed is for people that are really far down this, I call it web scale IT path, what you tend to have is an admin team that's generalist. They can manage the physical infrastructure, the storage, the compute, the networking. They may have some really cool kind of software overlays that go on top of it to provide virtualization or containerization or SDN or whatever that they don't deal with. Somebody else does it, but they can at least get the physical thing right. So having a data center that scales to a person or two people, you need enough stuff there that person can be kind of cost efficient. So that's one thing to keep in mind. That's using the minimal unit of deployment of a data center.
One human.
Yeah, one or two humans.
One and a half.
Yeah, exactly. There's another thing that a lot of people don't get their heads wrapped around, which is a recently modern phenomena, is the ability to buy aggregated power. So when Google started, and even Amazon started doing their big expansions, you could go and buy a whole power generation system's worth of power. So Google would buy that from a power municipality. They would drop resistors in the floor to burn the power because they would have a contract until they could fill the data center up. Wow. Okay, that doesn't exist as much anymore. So now what happens is you can't buy these big blocks of power. So it's really another limiter on how big of a data center you can build is how much power can I buy in a cost-effective way that's kind of guaranteed in any one geolocation.
Interesting. Very good. Any thoughts, Mansour?
I think it's both, really. I feel that latency is so dependent on the use case, right? If you're a self-driving car driving on 101, you better find a data center nearby. But if
what is the data center right now?
You better have all that shit in home. If you're home, if you're phone at home,
unable to locate the GPS, right? I can't locate data center, right?
But if I'm browsing Facebook,
that would not be good. Very good.
If I'm browsing Facebook separately from the car, not meaning not in the car.
I understand. All right,
if
there is
you
a
get an
question.
accident watching cat videos.
Yeah. I still think cat videos is just the way to go. Forget this DC stuff. Anyway, so this is an interesting question, which is maybe sort of a visionary one. I think maybe we have time for maybe one question, and we would like to get to wrap up. It's fast. Time goes fast when you're having fun, right? So.
Yeah.
So this question actually only addressed the Cumulus and Apstra, but I'm going to go a little further. So if three of you got together and had a love child, so not
Have a what?
Cumulus, love child. Cumulus, Apstra, and Innovium came together and had a love child. Like, this is actually the question. Well, I'm paraphrasing. Whomever else did, I apologize. So you get this self-diagnostic, self-configuring, self-healing, network can carry all the cat videos you want to watch, right? What would it look like? So in Innovium, right, merchant silicon, right, Cumulus switch, with the OS and Apstra sort of intent-based stuff, what does it look like? What does this thing look like?
So let me start, given I'm the bottom of the stack here.
Yeah, it's got blue eyes, right? What does this look like?
So I think, as we've heard from some of the panelists here, self-driving, self-automated, autonomous network is clearly very important for all these large-scale data centers, and maybe even large private cloud data centers as well. So we have to build in the instrumentation, the telemetry, the visibility, all of those in the ASIC to be able for the OS that JR would run on top, and then he would expose it to Apstra so that he can automate on a network-wide basis. So we spent a lot of time talking to customers about the kinds of problems. So first, they need to be able to troubleshoot the problem. They need to be able to quickly resolve the problem. Even better so, they need to be able to predict that the problem is going to happen soon. So those are the kinds of things. And then they need to run the analytics and see, hey, what are the kinds of things I can do to optimize? So those things we have to build in the merchant silicon. And that's what we have done as part of, not only have we done scale, so we do 3.2, 6.4, 12.8 terabit switches, but we've built in huge amount of telemetry, visibility, and analytic data that would be exposed through JR. He will pull it on a node-by-node basis. That would be aggregated in a central system. And that's how we see it. That's a key element of what a solution ought to be. Scale, visibility, analytics, and all the other associated things like low latency we talked about and so on.
So JR, you're the next level up on that.
Yeah, exactly. So I concur with Amit. The having approximating Amdahl's second law is kind of fundamental. That's what we would all hope to drive for in this love child that we're putting together.
You know what? I'll be the SI for that.
I'm just going to fund
Awesome.
it, Jer.
Yeah, we'll get his money. Yeah, we'll get his money.
Yeah. So the interesting piece is in the we'll call it the box resident piece of the system. You do two really important pieces. One is you make sure the topology forms and you react to changes in the topology. The other piece that people don't appreciate that much is when there's a tremendous amount of telemetry data, you can generate way more information than anybody can shove anywhere. The ability to digest that information and turn it into what are the interesting pieces is something that is really, really systemic and it's kind of underappreciated. Like, when we've worked with our at-scale customers, we're working with them to put we'll call it telemetry digesters on the switch so that it becomes a great big distributed computing engine. Then you take the output of that digested telemetry and you give it to somebody else to aggregate and turn into a systemic view of that result.
And he's waiting here.
Right. Maybe to just illustrate the power of disaggregation, right? So we work, with the operating system. I think we kind of pointed to that, but just to highlight this point, right? We rely on JR to do kind of, his job of, exposing these APIs. And that's, essentially what they're doing in a very reliable way of these APIs are being exposed. And so we don't then have to worry about, the specific APIs that Amit is exposing, right? That's his job. And this is really powerful because once we support Cumulus, then we can support anything that Cumulus supports underneath that, right? But so in terms of what is it that we're doing? Essentially, we're consuming all this telemetry, and so we have to build out this really large scale distributed data store to collect all this telemetry. We have to aggregate it in a way that essentially relates back to the intent, right? Are we delivering on the use case that the customer wants us to deliver on? And so there is a lot of aggregation, real-time analytics that are taking place. But then I think one thing that we didn't talk about much here is that these customers, whether they're web scale or large enterprise, they make tons of change operations. There were one large enterprise customer we're talking to, they do thousands of them a month, right? And so it becomes really critical that on our end, when we are as part of our autonomous operations, we're streamlining these change operations while making them as risk-free as possible, right? And so this is essentially the machinery that we would be adding at our layer, leveraging the capabilities of the layers below. And then when we are at our layer, then we're talking to other components, whether it's visualization or maybe overarching asset management, maybe time series databases that are doing long-term analytics, etc. Maybe to me, I'm relating this back to the whole theme of disaggregation and just highlighting the power of that approach.
Yep, that's good. Actually, I think that was a good last question to sort of wrap it up, right? I mean, we've taken the journey, right, starting with the economic dynamics of the data center, the changes, why now, why networking, why the workloads, right? And talked a little bit about why is it that the networking has not innovated as much, and we talked a little bit about those factors, and I think we delved a little bit into that. And I think we sort of took that journey, and then we're now at a point where basically I think we've sort of wrapped up and said, look, this aggregation does have value, does bring value, is really powerful, and I think just having three of you, I think it's kind of collusion here, right? You've got the different layers. We don't have that competition. We have three guys together and one guy to fund them all, right? But I think that last question leads to a very important point, which is this aggregation does have value. It's really valuable in how they can come together and sort of can create value. And I think if I was an incumbent sitting here, then I'd be comparing my Cisco 9K, right, versus do I go into that one or do I buy this one? And how do I compare sort of these two elements? And I think the bottom line is that if these three folks coming together can create something that powerful, right, to challenge the incumbents in networking, I think that is a pretty powerful statement for disaggregation right there. So I think that's.
Yeah, I mean, maybe I'll just nuance this by saying that
incumbent
doesn't necessarily mean not disaggregated, right? So I mean,
that's true. Well, no, I mean, there are incumbents who are disaggregating.
I mean, right? I think that So yeah, I think that we should. It's not this black and white.
Yeah,
right?
I mean, it's always gray.
Right.
Correct. I mean, even as an incumbent, as they embrace all these kind of layers.
But ultimately, there are the market forces that are there are the right architectures.
That's true. Excellent. Very good. Thank you. I think we're out of time. I think the panelists are willing to stay around a little bit to answer questions. I think many of you may have a lot more detailed questions to ask the panelists, and that they'll stay around a little bit after. But I think we have to wrap. But appreciate it. Appreciate the panelists. Thank you so much. It's been a pleasure.